On April 11, 2024, something happened in deep space that shouldn't exist. A massive star exploded in a distant galaxy. Astronomers named the event supernova SN2024GGI. But according to some of the most advanced simulations ever created, that explosion should never happen. Our most powerful computer models predict that stars like this should collapse quietly into black holes. Instead, astronomers watched it explode in real time, which means something doesn't add up. Either our understanding of physics is incomplete, or the universe behaves in ways our simulations still cannot reproduce. The discovery began at exactly 3:21 a.m. A robotic sky survey system called ATLAS detected a sudden flash of light in a distant galaxy known as NGC 3621. ATLAS is designed to constantly scan the sky looking for sudden changes. Most nights it finds nothing unusual, but this time, something new had appeared. Within just 5.8 hours, a previously faint star became one of the brightest objects in its galaxy. Astronomers immediately realized they were witnessing the birth of a supernova. When a massive star dies, its core collapses under gravity. The outer layers then explode outward into space. These explosions release more energy in a few seconds than our sun will produce in its entire lifetime. Supernovas are among the most powerful events in the universe. But despite decades of research, scientists still struggle to reproduce these explosions inside computer simulations. Modern astrophysics relies heavily on extremely complex models. Supercomputers simulate the collapse of massive stars using advanced physics and artificial intelligence. These simulations attempt to recreate what happens inside a dying star. But again and again, the models fail to produce explosions that match what we observe in the real universe. One of the most interesting experiments came from researchers at Caltech. They were testing a model where powerful magnetic jets blast outward from the collapsing star. In simplified simulations, the model appeared stable. But when scientists made the simulation more realistic, something strange happened. They introduced a tiny instability, just a 1% wobble in the star's rotation, and suddenly, the entire simulation collapsed. Inside the computer model, the jets of energy became wildly unstable. Instead of blasting cleanly outward, they twisted and tangled. Scientists compared the behavior to a garden hose whipping around uncontrollably when water pressure becomes unstable. The energy scattered in every direction, and the explosions simply failed. According to the simulation, the star should collapse quietly into a black hole. But the real universe did something completely different. When astronomers analyzed supernova SN2024GGI, they saw a powerful and symmetrical explosion expanding through space. Exactly the kind of explosion many simulations struggle to produce. Reality was doing something the models could not explain. Another explanation involves extremely tiny particles called neutrinos. During the collapse of a massive star, an enormous number of neutrinos are produced. Some scientists believe these particles may help push the explosion outward, but even neutrino-driven models still struggle to produce explosions as strong as the ones astronomers observe. In many simulations, the explosion energy is 10 times weaker than reality, which leaves astrophysicists facing a difficult question. What if our simulations are still missing something fundamental? Maybe there are physical processes inside dying stars we still don't understand. Or maybe the chaotic conditions inside collapsing stars amplify tiny instabilities in ways our models cannot fully capture. Supernova SN2024GGI is not just another exploding star. It highlights a gap between theory and reality. Despite our most powerful computers and most advanced artificial intelligence models, the universe is still doing things we cannot perfectly simulate. And that may be the most fascinating part of all, because every time the universe behaves in a way our models cannot predict, it means there is still something new left to discover. Somewhere in the violent collapse of dying stars, the universe may still be hiding physics we haven't found yet.